In the previous video, we have discussed about how to find the equivalent resistance of a combination circuit and how to find the total current in the circuit or the current flowing through the battery. Now in this circuit, we have three resistors, again a combination circuit. RH and RL are connected in parallel and R is connected in series to their combination. So we know how to find the total current in the circuit. But what if we need to find the current flowing through one of the resistors, let's say RH or RL or R? So how do you find that? 10 amps current is flowing through the battery. Okay, just a random number. 10 amps current is flowing through the battery. The same number of charges would be flowing through resistor R, that is 1.5 ohms, 10 amps, right? There is no other path for the electrons to flow. So the same 10 amps current would be flowing through R as well. But upon reaching this point, there is a junction, right? Some part of 10 amps current would be flowing through RH. Let's say 8 amps is flowing through RH. The remaining 2 amps would be flowing through RL, right? So the current would be different. These are not exact numbers, just took some random numbers. We're going to find out, right? To solve such problems, we need to understand Kirchhoff's laws proposed by a German physicist, Gustav Kirchhoff. Current law is pretty simple. The total current entering the junction is exactly equal to the current leaving the junction. Let's consider a junction in a circuit. This is a junction. Okay. Yeah. So I1, current I1 and I2 are coming towards the junction. I3, I4 and I5 are going away from the junction. So how do you write the equation? Total current entering the junction. So this is the junction, right? So the total current coming towards the junction, that is I1 plus I2, should be equal to the total current leaving the junction, that is I3 plus I4 plus I5, right? You can rewrite this as I1 plus I2. Take plus I3 to the left side, get minus I3, plus I4 to the left side, minus I4, plus I5 to the left side, minus I5, that is equal to 0. So this is called current rule or junction rule. Total current entering the junction is exactly equal to the current leaving the junction. Now voltage rule or loop rule, so consider a closed loop with multiple components connected across a battery. Let's say battery is providing, 30 volts, right? So battery is supplying 30 volts, right? So plus 30 volt. And let's say the potential drop across the first resistor is 10 volt. So the potential drop across the second resistor should be 20 volt. How does that work? Battery is providing plus 30, right? Plus 30. The voltage drop across this first resistor is 10 volt. So it's a drop, so minus 10 volt. The voltage drop across the second one should be 20 volt, so minus 20. That means if you add these numbers, plus 30, plus 30, plus minus 10, plus minus 20, you should get 0. In a closed loop network, the sum of the voltage drop around the loop is equal to 0. Another one, battery is providing, let's say 100 volt. The voltage drop across the first one is, let's say, 20 volt. Voltage drop across the second one is 30 volt. So what could be the voltage drop across the third one then? X. How do you find X? So this is a closed loop, right? It's a closed loop. Battery is providing 100 volts. So plus 100. 20 volt is getting dropped across the first resistor, minus 20. Minus 30 here. That's a voltage drop here. We don't know the voltage drop here. Let's call it minus X. It's a drop, so minus X. But if you add all these numbers, you should get 0. That's Kirchhoff's voltage rule. Total voltage in a loop is equal to 0. So plus 100 plus minus 20 plus minus 20 plus minus 30 plus minus x is equal to 0. So 100 plus into minus minus plus into minus minus plus into minus minus equal to 0. Take x to the right side. X equals 100 minus 20 minus 30, that is 50 volt. The voltage drop across the third resistor would be 50 volt. Makes sense, right? Battery is providing 100 volts. 20 volt is getting dropped across the first resistor, 30 volt across the second resistor, and the remaining 50 volt across the third resistor. So this is called Kirchhoff's voltage rule, also known as loop rule. Now let's get back to this problem. A hairdryer with a resistance of 12 ohms and a lamp with a resistance of 125 volt are connected in parallel to 125 volt source through a 1.5 ohm resistor in series. Find the current through the lamp when the hairdryer is on. Okay, so this is a combination circuit. Let's find the equivalent resistance of the circuit. RH is the resistance of the hairdryer, RL is the resistance of the lamp, and R is another resistor, 1.5 ohms. RH and RL are connected in parallel. So RH is in parallel with RL. Their combination is in series with R. So let's start with RH and RL. Let's find the equivalent resistance of RH and RL. 1 over RHL, the equivalent resistance of hairdryer and the lamp. 1 over RHL equals 1 over RH plus 1 over RL. 1 over RHL is equal to 1 over RH is 12 plus 1 over 125. If you solve it, you will get 137 over 1500. That is 1 over RHL. So RHL is the inverse of this, 1500 over 137. RHL is equal to 10.94 ohms. That means we can replace RH and RL with a single 10.94 ohms resistor, and the circuit would behave the same. Okay. Now we have R, that is 1.5 ohms, and the equivalent resistance of RH and RL, that is RHL. This is R. This is RHL. The equivalent resistance of RH and RL, that is 10.94, connected in series across a battery, right? So these two circuits are the same. They're connected in series. So how do you find the total resistance of the equivalent resistance? Req equals R plus RHL. R is 1.5, RHL is 10.94, 12.44 ohms. How do you find the total current in the circuit, or the current flowing through the battery? We can use Ohm's law. I equals V over Req. Total voltage is 125 volts. Total resistance is 12.44. 10.05 ohms. Let's go back to the circuit. Okay, so the current flowing through the battery is 10.05. 10.05 ohms, right? Okay, the same current would be flowing through resistor R. Let's call it I. So the current flowing through R would be 10.05 as well. There's no other path for the electrons to flow through. Yeah, so how do you find the voltage drop across this resistor? Voltage drop across this resistor, let's call it VR. Yeah, We can use Ohm's law, right? VR. How do you find VR? VR equals V equals IR. Multiply these two numbers, you'll get the voltage drop across this resistor, right? Ohm's law, I times R. I is 10.05 and R is 1.5. 15.075 volt. So the battery is providing 125 volts, and out of 125, 15.075 volts is getting dropped across the resistor R. 15.075 volt is getting dropped across resistor R. We need to find the voltage drop across these two resistors. Their voltage drop should be the same because they are connected in parallel, right? Yeah. Okay, so let's use Kirchhoff's voltage rule. Select a loop. Okay, select a loop, either this loop or this loop. Okay, yeah. So I'm going to select the second one, this loop. Okay, I'm going to draw that. I'll draw it here. So we have a battery. Resistor R. Okay, so this is my loop. Battery, resistor, and RH. RH. Back to the battery. So this is a loop now, right? The total voltage provided by the battery is 125 volts. And out of 125, 15.075 is getting dropped across resistor R. So what could be the voltage drop across resistor RH? How do you find that? Okay, so let's say VRH is the voltage drop across resistor R. This is VRH. How do you find that? So according to Kirchhoff's voltage rule, the total voltage in a loop is equal to 0, right? So battery is providing 125. So this is plus 125. This is minus 15.075. This is minus VRH. We don't know the value, but it's minus because it's a voltage drop. So how do you find VRH now? Plus 125. Total should be 0, right? Plus minus 15.075 plus minus VRH is equal to 0. 125 plus into minus minus 15.075 plus into minus minus VRH equals 0. Take minus VRH to the right side. VRH. That will be equal to 125 minus 15.075. VRH is equal to 109.925 volt. Makes sense, right? Battery is providing 125 volts and 15.075 is getting dropped across resistor R. The remaining 109.925 should get dropped across the second resistor, that is RH, right? So we got the voltage drop across RH. Voltage drop across RH is 109.925. That is a voltage drop across RH. But RH and RL are connected in parallel, so their voltage should be the same. So if RH has a voltage of 109.9, RL should have a voltage of 109.9. One more time. So we considered a loop, right? So we considered this loop, okay, with a battery that is 125 volts, resistor 1.5 ohms, and RH that is 12 ohms. That is my loop. And battery is providing 125 volts. voltage drop across resistor R can be found by multiplying current with resistance, that is 15.05075. We need to find the voltage drop across resistor RH, that is VRH. Okay, out of 125 volts, 15.075 is getting dropped across the first resistor. The remaining should get dropped across the second resistor. Simple mathematics, 125 minus 15.075 is equal to VRH. That is 109.925. Now, because RH and RL are connected in parallel, their voltage drop should be the same. We found the value of VRH, that is 109.9. Voltage drop across RL should be 109.9 as well. Now, how do you find the current flowing through RH and RL? Let's say IH is the current flowing through RH and IL is the current flowing through RL. How do you find IH and IL? So IH, I equals V by R, Ohm's law, right? V by R. But voltage across RH, voltage across this resistor, that is VRH, over the resistance, that is RH, 12 ohms. VRH is 109.9 over RH is 12, 9.16 ohms. Now, how do you find current flowing through resistor L, IL? The equation is V by R, Ohm's law. V is voltage drop across the second resistor, RL, over RL, right? Voltage is 109.9, it's the same voltage over 125 ohms, 0.88 amps. Or in simple words, if you want to find the current flowing through this resistor, find the voltage across this resistor, that is 109.9, and over the resistance, that is 12 ohms. That will give you the current IH, right? Now, if you want to find the current flowing through RL, voltage across RL, that is 109.9 over 125, that is IL, 0.88. Now, if you add these two numbers, 9.16 and 0.88, you'll get 10.04. That is almost the total current in the circuit, 10.05, right? It makes sense. The current flowing through the battery is 10.05, 10.05, 10.05. The same 10.05 would be flowing through resistor R. Upon reaching this junction, 0.88 would flow through RL, and the remaining 9.16 would flow through RH.